Tunisia, March 1943. Two Wehrmacht engineers knelt in the dust beside a charred American tube, already understanding that everything they knew about armored warfare had just become obsolete. The weapon weighed 13 pounds, a private could carry it, and it had just punched through the frontal armor of a Panzer III. For 3 years, German tanks had dominated European battlefields with a simple equation: steel thickness versus kinetic energy. The thicker your armor, the safer you were. Infantry with rifles posed no threat to a buttoned-up tank. Anti-tank guns were heavy, visible, required crews and positioning. You could see them coming, you could maneuver, you could suppress them with machine gun fire or high-explosive shells. This was different. The tube lying in the Tunisian sand changed the mathematics. It changed everything. Hauptmann Werner Osenberg picked up the weapon. He'd been sent from the Heereswaffenamt, the German Army Weapons Agency, specifically to examine captured American equipment. This one had been taken from a disabled half-track 3 days earlier near Kasserine Pass. The GY who'd been carrying it was dead. The weapon was intact. Osenberg had spent the morning measuring, weighing, sketching. Now he held it across his forearms like something sacred or dangerous. The distinction wasn't clear yet. The tube was smooth steel, 54 inches long, open at both ends. No complex mechanisms, no heavy breech. A simple electrical firing system, wire leads to a small battery, a basic trigger. Primitive, almost. Effective, absolutely. The projectile told the real story. Osenberg examined one of the captured rockets lying nearby. The M6A1 heat round, high-explosive anti-tank. Not a solid penetrator relying on kinetic energy. Not a conventional explosive relying on fragmentation. This was something else entirely, a shaped charge. The principle wasn't new. Swiss physicist Charles Monroe had documented the effect in 1888. German scientists Franz Rudolf Tomanek and Hubert Schardin had conducted extensive research in the 1930s. But weaponizing it effectively, making it portable and soldier-proof, creating something an infantryman could fire from his shoulder, that was innovation. The Americans had done it first. Osenberg could see the elegant simplicity. The rocket's warhead contained a copper liner formed into a precise cone. When the explosive detonated, the Monroe effect focused the blast into a superheated jet of metal plasma traveling at 25,000 feet per second. The jet didn't rely on momentum. It relied on pressure, tremendous focused pressure that could penetrate steel armor through sheer temperature and velocity. Thickness didn't matter anymore, at least not the way it used to. The bazooka could defeat 4 inches of rolled homogeneous armor. That meant it could penetrate the frontal armor of every German light and medium tank currently in service. The Panzer III, the Panzer IV in its early variants, the Sturmgeschütz 3 assault gun. Even the side armor of heavier vehicles was vulnerable, and any soldier could carry it. Osenberg's assistant, a young lieutenant named Krebs, had been photographing the weapon from every angle. He set down his camera and picked up the instruction manual they'd found with the equipment. It was water-damaged, partially illegible, written in that straightforward American style that assumed the reader had minimal technical knowledge. It says here, Krebs read slowly, translating as he went, that training time is 4 hours. 4 hours to teach a soldier to operate this weapon effectively. Osenberg looked up from his notes. 4 hours. The standard German anti-tank gun crew required weeks of training, months to achieve proficiency. The equipment was complex, the calculations demanding, ranging, windage, target leading, armor angle assessment. This weapon simplified everything. Point the tube, estimate distance, fire. The rocket did the rest. No recoil to manage. The backblast vented harmlessly behind the shooter. No heavy ammunition to hand load. No complex sighting systems. An infantryman with 4 hours of training could kill a tank that required 6 months to build, and crew members trained for half a year. The economic imbalance was staggering. Osenberg drafted his first report that evening by candlelight in a requisitioned farmhouse outside Tunis. His language was careful, technical, stripped of editorializing, but the implications sang through every line. The weapon's weight-to-effectiveness ratio represents a fundamental shift in infantry anti-tank capability, he wrote. Previous doctrine assumed infantry required dedicated anti-tank guns weighing 500 kilograms or more for effective armored vehicle engagement. This weapon weighs 6 kilograms and achieves comparable penetration at ranges up to 300 meters. He paused, pen hovering. Armored vehicles operating in close terrain can no longer assume immunity from infantry units lacking dedicated anti-tank support. That sentence would make it to Hitler's desk within a week. The German army had entered the war confident in a carefully constructed tactical philosophy. Armor and infantry worked in concert, but armor led. Tanks broke through. Infantry exploited. The panzer divisions racing across France in 1940, across the Soviet steppe in 1941. They'd operated with a kind of mechanical impunity. Infantry couldn't hurt them, not meaningfully, not without emplaced guns and good positioning. American industry had just handed every rifleman a tank killer. Osenberg knew the numbers. He'd memorized them from intelligence briefings. The Americans had produced 460,000 bazookas by the end of 1943. Not 460. Not 4,600. Nearly 500,000. They were manufacturing them at a rate that would have seemed impossible in any previous conflict. The weapon was being issued to U.S. infantry squads as standard equipment. Do the mathematics. A standard American infantry battalion contained roughly 850 men organized into 3 rifle companies. Each rifle company received 6 bazookas. That meant 18 bazookas per battalion, just in the rifle companies alone. Weapon platoons received additional units. The numbers multiplied across divisions, corps, entire armies. The Allied forces preparing for the inevitable invasion of Western Europe would bring tens of thousands of bazookas ashore. Every hedgerow could hide one. Every rubble pile in every French town could conceal a 2-man team with the firepower to cripple a 40-ton tank. Urban warfare, which had always favored defense, had just become infinitely more dangerous for armor. Osenberg's second report, submitted in April 1943, focused on tactical implications. In close terrain, urban areas, forests, mountainous regions, armored vehicles will face anti-tank threats from any position offering concealment. The weapon's lack of backblast signature compared to recoilless rifles provides additional tactical advantage to the operator. Detection prior to firing becomes extremely difficult. He was trying to be clinical. He was trying not to say, "Our tanks are going to die in the hedgerows of France." The report included recommendations. Tank formations should increase infantry support ratios. Reconnaissance elements should specifically search for anti-tank teams. Suppressive fire should be employed against all potential positions before armor committed to narrow terrain. Doctrine should emphasize combined arms integration at the lowest tactical levels. All sensible recommendations, none of them adequate, because the fundamental problem couldn't be solved through doctrine. You couldn't suppress every position. You couldn't scout every hedgerow. You couldn't provide sufficient infantry support in fluid tactical situations. And even when you could, the time required to do it properly meant losing speed, losing momentum, losing the operational advantages that made armor valuable in the first place. The German response came quickly. Too quickly, perhaps. When institutional panic meets engineering ambition, the result isn't always optimal. The Heereswaffenamt ordered immediate development of a comparable weapon system. The designation came down in May. Rockton Panzerbüchse 54, soon nicknamed the Panzerschreck, tank terror. Engineers at Rheinmetall-Borsig received the captured bazookas and the mandate to create something better. They made it bigger. The German mentality toward weapons design often followed a predictable pattern. If the enemy's weapon is effective, build something similar but more powerful. The Panzerschreck ended up with an 88mm caliber compared to the bazooka's 60mm. The rocket carried more propellant and a larger warhead. Penetration increased to 200mm of armor, nearly 8 inches. But the weapon also weighed 20 pounds instead of 13. It required a frontal blast shield because the rocket's exhaust was fiercer. It was harder to manufacture, requiring more precision machining and better materials. Germany, in 1943, had neither time nor resources for complicated solutions. The development process revealed deeper problems. American engineers had designed the bazooka with mass production in mind: simple components, minimal machining, materials available in quantity. The weapon could be manufactured in facilities that had never built military equipment, automotive plants, agricultural equipment factories. The industrial capacity of the entire American economy could be turned toward bazooka production with minimal retooling. German industry worked differently. Precision engineering, skilled craftsmen, complex supply chains already strained by competing demands. Building Panzerschrecks meant diverting resources from other programs, allocating steel that could build tank armor, consuming machine time needed for artillery production. The first Panzerschreck units reached frontline troops in late 1943. By then, the Italians had already developed their own response, the Panzerfaust, a simpler single-shot design that prioritized ease of manufacture over reusability. The Panzerfaust was brilliant in its expendability. No complex launcher, no sophisticated electronics, just a tube, a shaped charge warhead, and a propellant charge. Fire it once and throw it away. Germany would manufacture 8.3 million Panzerfausts before the war's end. The number tells you everything about desperation and doctrine. Production of that scale required wholesale conversion of industrial capacity. By 1944, Panzerfaust manufacturing consumed resources equal to building 1,500 medium tanks annually. The choice was stark: build tanks or build tank killers, build offensive capability or defensive capability. Germany chose defense because offense was no longer possible. But weapons proliferation couldn't solve the underlying problem that Ozenberg had identified in Tunisia. The problem wasn't just tactical, it was philosophical. For 3 years, German armored forces had enjoyed a psychological advantage as profound as any technological edge. When panzer columns appeared on the horizon, infantry units, especially poorly equipped infantry units, felt terror. Rational, justified terror. You couldn't hurt a tank with a rifle. You could barely hurt it with a machine gun. Your options were limited. Hope for artillery support, hope for air support, hope your anti-tank guns were positioned correctly, or run. The bazooka changed the psychological equation. Now, every hedgerow was dangerous. Every alley, every barn, every basement window. The Americans knew it. The British adopted similar weapons, including the PIAT, projector, infantry, anti-tank, a spring-powered system that was less effective than the bazooka but required no propellant gases and could be fired from enclosed spaces. The Soviets mass-produced their own versions, the RPG-1 and the later RPG-2. By 1944, every major army fielded portable anti-tank weapons for infantry units. The age of armored impunity had lasted less than 5 years. Ozenberg spent late 1943 and early 1944 attached to various panzer units, observing how the new tactical reality manifested in combat. He was present during the fighting in Italy, where American and British forces employed bazookas with increasing effectiveness in the mountainous terrain south of Rome. One engagement stayed with him. October 1943, outside a village called San Pietro in Fine. A Panzer IV company, 10 tanks, attempted to advance through a valley constrained by steep hillsides, good terrain for defense, terrible terrain for armor. The company commander knew it but had received orders: advance, support the infantry assault, clear the position. The tanks moved in column because the valley was too narrow for any other formation. They moved slowly because the road was damaged. They moved predictably because there was only one route. 4 bazookas opened fire within 30 seconds. 2 from the right hillside, concealed in rubble. 2 from the left, hidden in a collapsed barn's stone foundation. The range was less than 150 meters. The targets were nearly stationary. 3 tanks burned before the formation could react. The lead vehicle took a rocket to the engine deck. The penetration ignited fuel lines and ammunition. The crew had perhaps 15 seconds to escape. 3 made it out. 2 didn't. The second tank in column took a hit to the turret ring. The round penetrated but failed to detonate the ammunition. The crew bailed immediately, scrambling through hatches as smoke filled the fighting compartment. The third kill was textbook. A rocket struck the side armor at a 90-degree angle, punching through below the turret. Internal detonation. The tank didn't burn. It exploded. Magazine cook-off. Turret lifted 3 feet into the air and settled back crooked. The company reversed, leaving 2 immobilized vehicles to be destroyed at leisure. The infantry assault failed. The position held for another week until artillery finally reduced it. Ozenberg interviewed survivors afterward. What struck him wasn't the tactical details. Those were predictable, even obvious in retrospect. What struck him was the psychological impact. "We couldn't see them," one commander said. "We knew they were there. We knew they had those weapons, but we couldn't see them until they fired. And then it was too late." Another commander, a veteran of France and Russia, put it differently. "In Russia, you know where the anti-tank guns are. You can see them. You can maneuver. You can call artillery. This is different. This is every window, every wall. You can't suppress what you can't see." The hunters had become the hunted. Tank doctrine evolved, had to evolve, but the adaptations were expensive. Tanks began requiring more infantry support, closer infantry support, infantry specifically tasked with suppressing anti-tank teams before they could engage. This slowed advances. It made combined arms operations more complex. It required coordination that was difficult to maintain in the chaos of combat. Standard operating procedures changed across the Wehrmacht's armored divisions. Before 1943, tank platoons routinely operated semi-independently, exploiting breakthroughs, pursuing retreating forces, conducting reconnaissance by fire. After 1943, doctrine emphasized staying with supporting infantry. Maximum distance from infantry support, 200 meters in open terrain, 50 meters in close terrain. Those numbers represented a profound loss of tactical flexibility. Armor thickness increased. The later Panzer IV variants received additional frontal armor. The Panther tank, introduced in mid-1943, featured sloped armor specifically designed to deflect shape-charged jets. The Tiger tanks already possessed armor thick enough to resist bazooka attacks from most angles. But heavier armor meant heavier tanks. Heavier tanks meant more stress on engines, transmissions, suspensions. More stress meant more mechanical failures, more fuel consumption, slower speeds, greater difficulty crossing bridges, navigating soft ground, operating in restrictive terrain. The Panther weighed 45 tons. Its Maybach HL-230 engine produced 700 horsepower. Impressive, but barely adequate for the mass. Transmission failures plagued the design. Final drive failures occurred after as little as 150 kilometers of operation in early production models. The tank was designed to counter threats that included shaped charge weapons, but the design created new vulnerabilities through mechanical complexity. The arms race spiraled. By 1944, American forces were fielding the M1 Bazooka with improved rockets. The Germans responded with even larger Panzerschrecks and more Panzerfausts. The Soviets developed the RPG-2. The British improved the PIAT. Everyone was trying to kill tanks more efficiently. Everyone was succeeding. The impact on tank losses was measurable and stark. Analysis of German armored vehicle write-offs in Western Europe after June 1944 shows that infantry anti-tank weapons accounted for approximately 23% of total tank losses, higher than losses to enemy tanks, comparable to losses from air attack. In urban combat zones like Aachen or the approaches to the Rhine, the percentage climbed higher. Operational research conducted by U.S. Army observers in France during late 1944 documented the tactical effectiveness. In hedgerow country, bazooka teams averaged 1.8 kills per team before being neutralized through casualties or ammunition exhaustion. In urban terrain, the average climbed to 3.4 kills per team. The weapons were most effective at ranges under 100 meters, where accuracy was high and reaction time limited. German armor commanders adapted their movement patterns. Instead of deliberate advances with infantry, tanks in urban areas began using rapid rushes, closing distance quickly, minimizing exposure time. Fire superiority became less important than speed. Getting through the danger zone mattered more than controlling it, but speed had costs. Faster movement meant less situational awareness, less ability to identify threats, less time for supporting infantry to clear buildings. The tactical choice became move slow and get targeted, or move fast and potentially drive into ambushes. Neither option was good. The Battle of Berlin in April and May 1945 provides the most extreme example. Soviet armored formations entering the city faced Panzerfaust teams in every block. German defenders, often Volkssturm militia with minimal training, could hide in any building, fire at close range, and disappear into the rubble. Soviet tank losses were catastrophic. The Red Army lost over 2,000 armored vehicles taking Berlin, many to shoulder-fired weapons operated by teenagers and old men. The weapon's effectiveness in that environment wasn't surprising. Urban terrain provided ideal conditions, short engagement ranges, abundant concealment, limited maneuver space for tanks. What was remarkable was the operator's effectiveness despite minimal training. A 16-year-old Volkssturm conscript with 2 hours of instruction could kill a JS-2 heavy tank worth hundreds of thousands of rubles and crewed by veterans of Stalingrad and Kursk. The tactical evolution accelerated. Tank commanders began requesting flamethrower support to clear buildings before entering streets. Infantry tactics emphasized suppressive fire on any potential anti-tank position. Tanks moved faster in urban areas, minimizing exposure time, accepting reduced accuracy in favor of survival. But speed and suppression only worked to a point. The fundamental reality remained. A soldier with a tube and a rocket could kill a tank worth 50 times his annual salary, could kill a machine that required thousands of man-hours to produce, could kill a weapon system that embodied industrial supremacy. The economic equation had shifted. Germany's response, manufacturing millions of Panzerfausts, reflected a grim acceptance. You couldn't protect your tanks from these weapons, not reliably. So you gave your infantry the same capability and hoped the exchange rate favored you. Hoped that killing enemy tanks would offset losing your own. It didn't, of course. Germany was losing the industrial war by 1944, losing the manpower war, losing the fuel war. Portable anti-tank weapons didn't change the war's trajectory, but they accelerated the endgame. They made German armored reserves less effective. They made every defensive position more dangerous. They complicated counterattacks and mobile defense. They made tanks mortal. After the war, Osenberg was interviewed by American technical intelligence teams. The transcripts are dry, bureaucratic, focused on weapon specifications and development timelines. But one exchange stands out. The interviewer asked, "When did you realize the bazooka would change armored warfare doctrine?" Osenberg's answer, "Tunisia. The first day." The weapon's existence demanded a re-evaluation of every tactical assumption made since 1939. The interviewer pressed, but German forces continued to rely heavily on armor. "Yes," Osenberg said, "because we had no choice. The alternatives were worse, but we relied on armor knowing it was no longer decisive, knowing it was vulnerable. That knowledge affects everything: planning, morale, risk calculation." He paused. The tank didn't become obsolete, but it became mortal. There's a difference. That difference defined post-war armored vehicle development for decades: reactive armor, composite armor, active protection systems, defensive countermeasures. The entire trajectory of tank design after 1945 was, in many ways, a response to that moment in Tunisia when German engineers examined a 13-pound American tube and realized the rules had changed. The bazooka's descendants proliferated globally. The RPG-7, introduced by the Soviet Union in 1961, became the most widely produced anti-tank weapon in history. Over 9 million units, available to state militaries and insurgent forces alike, the pattern repeated. Inexpensive weapons threatening expensive vehicles, asymmetric warfare codified in steel and explosives. Production costs told the story. An RPG-7 launcher cost approximately $500 to manufacture in the 1960s. The rocket-propelled grenades cost $100 each. A Soviet T-55 tank cost $120,000. An American M60 cost $250,000. The economic imbalance that Osenberg identified in 1943 had grown more pronounced by the 1960s and 1970s. Modern anti-tank guided missiles, TOW, Javelin, Cornet, represent the logical evolution of the principle that Osenberg identified in 1943. Infantry can kill tanks. A small team with a portable weapon can destroy a vehicle costing millions. The economic imbalance favors the attacker. A single FGM-148 Javelin missile costs approximately $80,000, expensive by infantry weapon standards, cheap compared to the $8.5 million price tag of an M1A2 Abrams tank. The cost ratio is 1 to 106, and the Javelin's top attack profile defeats most existing armor protection systems. Tank designers responded with increasingly sophisticated defenses, reactive armor blocks that detonate outward to disrupt incoming warheads, slat armor to pre-detonate rockets before they reach the hull, active protection systems that intercept projectiles mid-flight, but each defensive advance adds weight, complexity, cost. The tank became heavier, more expensive, more difficult to maintain and deploy. The M1A2 Abrams weighs 73 tons. Its gas turbine engine consumes 10 gallons of fuel per mile under combat conditions. It requires extensive logistics support. It cannot deploy to many regions because bridges cannot support its weight and transport aircraft cannot carry it efficiently. Some military theorists argue the main battle tank is approaching obsolescence, a victim of the same technological democratization that the bazooka pioneered. Others countered that tanks remain essential for combined arms operations, that rumors of armor's death are premature, that adaptation continues. The debate echoes arguments from 1943. What's certain is that armored warfare never recovered its early war character, the sweeping advances, the mechanical invincibility, the psychological dominance. After 1943, tanks operated knowing that threats existed everywhere, that any terrain offering concealment could hide a weapon capable of killing them. The 13-pound tube lying in Tunisian dust represented more than tactical innovation. It represented a shift in military economic calculus. It proved that industrial warfare's dynamics could be disrupted by asymmetric solutions, that expensive platforms could be countered by inexpensive weapons, that complexity could be vulnerable to simplicity. Ozenberg's report circulated through Wehrmacht command structures throughout 1943 and 1944. Tactics evolved, training changed, but the underlying problem resisted solution. You couldn't make tanks invulnerable without making them impractical. You couldn't eliminate the threat without controlling every meter of terrain. And Germany couldn't control terrain by 1944. The Eastern Front consumed divisions. The Mediterranean Front demanded reinforcements. The inevitable invasion of France would require every available unit. German forces were spread thin, reacting to Allied initiatives, losing the strategic offensive. In that context, the bazooka was one more problem without a good solution, one more threat to manage, one more way for the war to go wrong. But for the soldiers in the tanks, it was personal and immediate. Every advance through close terrain meant running a gauntlet. Every street in every contested town meant exposure. Every mission carried odds that had been acceptable in 1940 and were barely survivable in 1944. The crews knew. They'd seen the burned-out hulks. They'd heard the stories. They'd pulled wounded comrades from penetrated fighting compartments. They knew that somewhere, in the tree line or the rubble, someone might be shouldering a simple tube, might be tracking their vehicle, might be waiting for the right moment and the right angle. Knowing changed how they fought, made them cautious when doctrine demanded aggression, made them hesitate when hesitation could be fatal. The psychological burden was invisible but measurable in outcomes. Tank crew quality declined throughout 1944 and 1945 as experienced veterans died and were replaced by hastily trained conscripts. Training time for German tank crews dropped from 6 months in 1942 to 6 weeks by late 1944. New crews arrived at frontline units without having fired their main guns or practiced coordination drills. They faced enemies equipped with weapons that required far less training to use effectively. The asymmetry was unsustainable. The bazooka didn't win the war. The Allies won through industrial capacity, strategic bombing, naval supremacy, code-breaking, and the Red Army's enormous sacrifice. The bazooka was a footnote in that larger story. But footnotes matter. Innovations compound. Technologies proliferate. The principle proven in 1942 when American ordnance engineers finalized the M1 launcher design, that infantry could carry tank-killing firepower, became foundational to post-war military thinking. shaped the Vietnam War, where RPGs devastated American armor, shaped Afghanistan, where Mujahideen with Soviet-supplied weapons destroyed hundreds of tanks, shapes contemporary conflicts where insurgent forces employ anti-tank weapons against government armor. The pattern repeats because the economic logic remains unchanged. A $50,000 missile can destroy a $6 million tank. A guerrilla fighter with 2 weeks of training can kill a vehicle crewed by soldiers trained for months. The math favors the attacker. Osenberg survived the war. He returned to technical work in the German chemical industry, his wartime service a closed chapter. He didn't publish memoirs. He didn't give many interviews. His reports moldered in captured archives, occasionally referenced by historians studying weapons development. But his assessment from Tunisia remained accurate. The weapon's existence demanded reevaluation of every assumption. That reevaluation continues. Modern militaries still struggle with the fundamental problem. How do you protect expensive, complex vehicles from inexpensive, simple weapons? How do you maintain armored warfare's viability when the defense constantly evolves faster than the threat? Some answers involve technology, better armor, better sensors, better countermeasures. Some involve doctrine, better combined arms integration, better terrain analysis, better risk management. Some involve accepting limitations, acknowledging that certain terrain, certain tactical situations, certain operational contexts make armor use inadvisable. None of the answers restore what was lost in 1943, the age when tanks could dominate battlefields through intimidation and protection, when armor meant safety, when crews could button up and feel confident in steel walls. That age ended in Tunisia with a 13-pound tube. The engineers who examined it understood immediately, though understanding didn't help. Knowledge without power to change outcomes is just witnessing. They witnessed the future of armored warfare and recorded their observations and sent reports up chains of command. The reports were read, filed, occasionally acted upon. The war continued. Tanks burned in Italy, in France, in Germany, in Berlin. Some from enemy tanks, some from anti-tank guns, some from aircraft, and increasingly, some from soldiers in foxholes and basements and hedgerows, carrying simple tubes loaded with shaped charge warheads, waiting for targets to come within range. The mathematics of warfare had changed, not overnight, not completely, but fundamentally. The principle that expensive platforms required expensive counters had been disproven. A new principle emerged. Asymmetric solutions could defeat symmetric superiority. Cost-effectiveness mattered more than absolute capability. That principle would define military development for the remainder of the 20th century and beyond. Would shape procurement decisions and tactical doctrine and strategic planning. Would force armies to reconsider the role of armor in modern warfare. Would remind military planners again and again that innovation comes from unexpected directions. That advantage is temporary. That superiority invites countermeasures, that the weapons defining one war may be obsolete in the next. The hunters had become the hunted, and the equation never balanced again.